Now more stuff you've seen before, except we're going to write the answers in interval notation. How do you solve part A, 3/4 x minus 2 is greater than 7? If you had a friend who knew how to solve equations but didn't know how to solve inequalities, what would you tell that friend? Yeah, in other words, solve it just like it's an equation, right? Yeah, pretend the greater than is an equal sign. Now, there is one little trick to that, one little curveball in there that some of you might remember. We'll talk about that in a minute. We don't have to worry about it here. So, okay, so what would be your first step in solving for x? Okay, add 2 to both sides. And what does that give us? 3/4 x is greater than, right? 7 plus 2, 9. Does that make sense to you? Yeah, there's no reason why you shouldn't be able to add the same thing to both sides and have the greater than stay right where it is. Okay, then if this were an equation, 3/4 x is equal to 9, how would you solve it? Yeah, you could divide both sides by 3/4, which is the same as multiplying by the reciprocal 4/3, isn't it? So let's just cut to the chase and multiply both sides by 4/3. And then you can see what's happening. The 3's cancel, the 4's cancel, and you're left with x. There's no reason why the greater than wouldn't stay right where it is. And then, is it easier to multiply 9 times 4/3 or divide first? Yeah, think of it as 9 over 1. So 3 goes into 9 3 times, and then multiply straight across. Oh, so what do you get? Just 12 over 1, right? Okay, so 12. And then let's see if we can write that in interval notation without drawing the number line. Can you imagine what the number line graph would look like? It would go from shaded, it'd be shaded from what to what? 12, and then which direction would you shade? It'd be shaded at 12, and then you'd shade to the right. Would you include 12? No, so if you imagine what that graph looks like, and you lop off the number line part of it, it starts at 12, right? And then it goes up from there. Well, that means it goes to infinity. Is the 12 included? Nope. So what's kind of symbol around the 12? Do you ever get to infinity? Nope. So what kind of symbol around the infinity? Yeah. Now, guys, if you're ever confused, just draw the number line. It's no big deal. It doesn't take that long. So 12, I shade to the right. I realize infinity's out here somewhere. Oh, so my interval notation's good. Oh, and it is got to be a left parenthesis around the 12 because it's a strict inequality. That's the reason, right? Doesn't have to do whether it's less than or greater than. It has to do with whether or not it has a little line underneath it. When it has a line underneath it, then the number's included. When it doesn't, the number's not included. Any questions? So that's the answer. In part B, we want to solve the inequality. We have 4 times the quantity z minus 1 plus 2 on the outside is greater than or equal to the quantity 3z plus 8 minus 2z. Again, treat it like it's an equation. So what do you get rid of first? Remember, if you want to be able to manipulate the z, there's multiple occurrences of the variable, right? Z. If you want to be able to get the like terms together, the like z's together, then you got to get it outside the parentheses. So you got to get rid of the parentheses first, which in this, on the left side anyway, means distribution. So help me out here. What do I get when I distribute? 4z minus 4 plus 2. Parentheses gone, right? Now the left side, I'm sorry, that was the left side. The right side, 3z plus 8 minus 2z. Are those parentheses doing anything? Now I could just drop them and go ahead and combine like terms. So what do I get on the right side? How many z's? 3z minus 2z, 1z, or just z? My son used to wear a 1z. That's a joke that most of the guys in here won't get. Because most men, let's face it, are afraid of babies until they have one. And maybe even then, I don't know. I was afraid of dropping my son when I first got him. Then you don't worry about it. Eventually you realize, oh, they're not going to break. And they're fine. Not that it's okay to drop them, don't get me wrong. Okay, let's combine the like terms together. We are going to run out of time if I keep talking about nonsense. 4z, okay, minus 4 plus 2. Minus 2 greater than or equal to z plus 8. So it's always nice to combine the like terms on either side first and then get the like terms from opposite sides together. So I see a z here. I see a 4z here. How about we subtract the z's from both sides? Can we do it all at once and get the constant to the right side? Help me out. How would I do that? Add 2. Add 2. Okay. So what does that get me? 3z is greater than or equal to 10. And what would I do then to solve for z? Divide both sides by 3. Z is greater than or equal to 10/3. Okay, interval notation. You would, if you were to graph on a number line, you would plot 10/3, and which way would you shade? To the right. So it'd go from 10/3 to positive infinity. Does it include 10/3? So what kind of symbolism do you use around 10/3? Bracket. Never get to infinity, so parenthesis around that. 10/3 to infinity, that interval, including 10/3, is your solution interval. For part C, negative 5x plus 2 is greater than or equal to 12. Let me remind you of something before we do this example. Remember the trick where if you multiply or divide both sides by a negative, you have to switch the direction of the inequality? Let me just show you why that's true real quick, because a lot of students don't remember why that's true. It's really simple. Does everybody agree that 3 is less than 5? Okay, what happens if you multiply both by a negative? You end up with negative 3 and negative 5. Is it still true? If I left that less than there, would it still be true? No, because negative 5 is actually further to the left on the number line than negative 3 is, right? So negative 3 is bigger. So all you have to remember is every time you multiply or divide through by an inequality by a negative, you switch the direction of the inequality because well, it's going to end up with something like that if you don't. I mean, well, when I say like that, I mean like what you got when you didn't switch it. Okay, so let's solve this. And remember that little trick. Subtract 2 from both sides, negative 5x. It's greater than or equal to what? 10. Then you divide both sides by negative 5. Circle the inequality so you don't forget to switch it. And what do you get? X is less than or equal to negative 2. We switched to the inequality because we divided through by a negative 5. Okay, negative 2 is, okay, if x is less than or equal to negative 2, if you were to graph this on the number line, you would shade in which direction? To the left. So the negative 2 is the biggest number in interval notation. That goes on the right. And then if you go to all the way to the left, what do you hit? Negative infinity. Okay, you never get there, but we'll pretend like you do. Negative infinity. Okay, you never get there, so parenthesis around the negative infinity. What about around the negative 2? Bracket, because it's included, right? Question, real quick. Yes, it totally matters. If you have a negative infinity, it should always be on the left. If you have a positive infinity, it should always be on the right.